In this video, we're going to talk about application vector for vector geometry. Now, you already learned this before, that when two lines are parallel, right? Let's say you have vector AB and CD, they are parallel, two lines. So AB must be a multiple of CD. So our goal is to find what is your lambda. Yeah, a multiple of CD means lambda is a scalar quantity. We just have to find it. So let me show you one example. Let me give you one example. Let's say you have a diagram like this, okay, where this is O, B, Q, R, and let's say you have a point here. This is point S, and this is point T, such that S is the midpoint of OR, right, and T lies on PR, such that the ratio is 1:2. Now, at the same time, PQ OR has a ratio of 3:4. Let's say 3:4. Okay. So now, how do you show, okay, that ST is parallel to RQ? So now we know, let's say OP is given as 3P and OR is 4R. So this will be 2R, 2R. Okay, because S is the midpoint. So number one, I need to find vector, let's say ST first. Okay, now to go from S to T, I can go from S to O, O to P, P to T, S to O, O to P, P to T. SO is negative 2R. Yeah, when you go against the direction of the vector, it's minus. Then OP is 3P, just add 3P, follow the same direction, so it's positive. And PT is 1/3 of PR. Now, we know vector PR we can find, we can go this way, yeah? That is, let me simplify this. PR is negative 3P plus 4R. So when I expand the bracket, I'll get negative P plus 4/3R. 3P minus 1P is 2P. 4/3 minus 2 is going to give us negative 2/3R. So I know vector ST already. Now, I also need to find vector RQ. Maybe I write over here. RQ means I go R to O, O to P, P to Q. Now, by the way, if PQOR is 3:4, so this should be 3R. Yeah, because the whole thing is 4R here, this is 3R, the ratio is 3:4. Yeah, this is given. So RQ will be minus 4R plus 3P plus 3R. If you put it together, you get 3P minus R. Okay, remember, to show that ST is parallel to RQ, we must write ST as a multiple of RQ, in this case lambda RQ. So ST is 2P minus 2/3R. RQ is 3P minus R. Now, if you find the fractions a bit difficult, a bit annoying, what you can do is you can multiply everybody by 3. So this would be 6P minus 2R equals to 3 lambda. Keep the 3 outside, don't need times inside. And 6P 2R we can take out, 2. Left with 3P minus R. So in this case, it's quite obvious, right? We can cancel out the 3P minus 2R and solve for lambda. My lambda is 2/3. If I can show that ST is 2/3 of RQ, we know ST must be parallel to RQ. Okay? Now, let's move on. For collinear points, we know that if 3 points are collinear, you can say that maybe, for example, point A, point B, and point C, they are collinear here, right? So we can use the concept similar to parallel, because when the points are collinear, can we say that, let's say AB and DC, they are parallel. If I copy and paste over here, not only that they're parallel, they are also collinear, right? So we can say AB in this case is a multiple of BC. Or you can say AB equals to a multiple of AC, correct? Because AB parallel to BC, AB also parallel to AC, and also we can say BC is parallel to AC. Now, the difference is this three different combination has three different common points. The first one, my common point is B. The second one, my common point is A. You can see from here, the common alphabet. And the third one, my common point is C. You can use any one of these three options. Doesn't matter. Yeah, they all will give us the same result. Okay, I'm going to give you one example. Okay, so I'm going to use maybe a triangle. Let me just draw a triangle for you. So you must know all this given information. One more time. So I draw, say, a triangle like this. Let's say this is point O, this is X, this is Y, and this is W. W lies on OY such that the ratio is 1:3. Let's say this is 1Y, this is 2Y. The whole thing is 3Y. And let's say OX is 3X. And you have a point here, V. V is a midpoint of XY. And you have point U here such that this ratio is 3:1. So, in order to show or prove that OUV are collinear, you can use any combination OU, UV, OU, OV, or UV, OV, up to you. So I think I can find, I use OU, OV, it's easier. So let's start with OU. OU is O to W, W to U. You can even use O to X, X to U. OW is Y, WU is 1/4 of WX. And WX you can find from here, minus Y plus 2X. Okay, when you put it together, you will get 1/2X plus 3/4Y. Okay, how about OV? OV, we can use O to X, X to V, O to X, X to V. Now, O to X is 2X, XV is half of XY. Now, XY is minus 2X plus 3Y. Okay, minus 2X plus 3Y. So when you simplify this, you get single X, 3/2Y. Okay, the next thing is I can take OU equals lambda OV. When they are collinear, 3 points lie on the same line. OU should be a multiple OV. So I know OU already, which is half X, 3/4Y. I know OV also, X, 3/2Y. So now we have fraction here. So maybe I multiply here by 4, right? So when you multiply by 4, this will give us what? X, 2X plus 3Y times 4. This would be 4X plus 6Y. And we can take a common factor here. Take out 2. This is 2X plus 3Y. You can cancel these 2. And 2 lambda is now 1. Lambda is half. So OU is half of OV. Therefore, we can say that since O is a common point, therefore OU, V are collinear. Okay, now if they ask you to find a ratio OU, OV, then we can say OU, OV is 1:2. Right? Okay. They can also ask you to find the value unknown given collinear points or even parallel lines. Okay, let me show you one example. Let's say I know vector AB, and AB is, let's say, I just use random number 4p minus 2kq, and you're given vector CD. CD is, let's say, k plus 1p 15q. Now this one is parallel. If I change this to BC, then they will be collinear, but essentially it's the same. Yeah, collinear, parallel. When it comes to proving, showing them, it's the same. The difference is collinear, you have a common point. So I'm just going to use CD for now. Okay, so number one, we know when they're parallel, AB is a multiple of CD. So you take 4p minus 2kq equals lambda k plus 1p minus 15q. Okay, so when you multiply inside, lambda k plus 1p minus 15 lambda q. by comparing vector P, I get 4 equals to lambda k plus 1, first equation. By comparing vector Q, minus 2k is negative 15 lambda. I think we can just drop the negative, right? 2k equals 15 lambda. So for me, I wouldn't want to use substitution. I just use division. I take equation 1, divide equation 2. So 4 over 2k lambda k plus 1, 15 lambda. We can cancel lambda, cancel 2 and 4. So you cross over, this is 30 equals k plus 1. So k squared plus k minus 30 is 0. We can double bracket factorize them. It should be 6 and 5. So k, let's say k is positive. So normally exam will narrow down. They say, let's say k is a positive value. So we ignore negative 5, negative 6, we take positive 5. And if you want to find the ratio A, B, C, D, just take the k value and sub inside. Maybe I sub in equation number 2. So 2 times 5 is 15 lambda. Lambda is 10 over 15, 2 over 3. So if your lambda is 2 over 3, we can just sub back. AB equals 2 over 3 CD. AB CD is 2 over 3. So when you write in ratio form, we call it a proportion form. We don't put vector divide vector. It's mathematically incorrect to divide vector another vector. So we drop the arrow, the vector notation. We just write in this form in a scalar quantity. So ABCD has a ratio of 2:3. Alright, okay. So now the next part. Let's talk about finding a value unknown given two lines intersect. It is rather similar to collinear parallel, just that you're not given the unknown. So let's say I give you an example of parallelogram. So this is O, and this is vector P, this is vector point P, R, and Q. This is, let's say, 3Q, and OR, R here, and PQ, they do intersect here, such that the ratio is lambda and mu here, right? So what I want to do is to find the value of P, lambda and mu. Okay, some other information must be given. PR, OQ, let's say the ratio is 2:3, right? I think that should be sufficient. So we put a 2, this is a 2Q here. Okay, sorry, a bit my diagram is a bit too high. I cannot write above here. So now let's start. In order to find, let's say, lambda and mu, we need to find two versions of OS. The first version of OS, we can go from O, maybe we can say OS is a multiple lambda of OR. And OR, we can go from O to P, P to R. In this case, it's P plus 2Q. Yeah, sorry, this is 2Q, like I say. So this is lambda P plus 2 lambda Q. The second vector of version of OS is I can go from O to P, P to S. Then your answer will be involving mu. So OS equals to OP plus PS. Usually they will tell you PS is mu PQ. So we have to find vector PQ now. In this case, PQ should be minus P. Okay, let me put a mu first. Put the mu first. Minus P plus 3Q. So when you put it together, this is 1 minus mu. The negative it times in, so it's minus mu. Put together, factorize the P, and 3 mu Q. So notice you have two versions of OS. The first version in terms of lambda, second version in terms of mu. So let's just compare vector P for both. First one, lambda is now 1 minus mu. Keep this first. The second equation will be Q. We say 2 lambda equals to 3 mu. As I sub equation 1 inside equation 2, 2 of lambda is now 1 minus mu, is now 3 mu. So 2 minus 2 mu is 3 mu. 5 mu is 2. Mu is 2 over 5. Now, if you want to find lambda, you just sub inside equation number 1. Lambda is 1 minus 205, 305. Simple, right? Okay.